Today, I want to give you an introduction to blockchain development with JavaScript. Okay, we're going to use Web3.js to talk to Ethereum. You don't have to really know anything about blockchain, Ethereum, or JavaScript to follow along with this video, right? I'm going to teach you everything from square one. So I've released a few different videos about Web3.js on my channel before, and I've put a bunch of them all together in one place. We're going to go through all these different examples with Web3. They're going to teach you about the basics of being a blockchain developer, right? I'm going to take you through each of those and walk you through step by step. So before we do that, hey, I'm Gregory from Dapp University, and be sure to like this video and subscribe to the channel, all right? That really helps this video get found so that more people can learn how to build blockchain technology, okay? And if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. So there's a few different aspects to, developing decentralized applications with Ethereum. On the one hand, you've got, smart contract development where you're actually writing code that's going to get deployed to the Ethereum blockchain. But there's the other half of the equation, which is, developing a website or a client of some kind that can actually talk to the blockchain. And that's where the Web3.js library comes into play. It gives us a way to build a website, or any kind of client for that matter, really, that can talk to the Ethereum blockchain. So if you come from a web development background, you might be familiar with developing a website that talks to an API or a server of some kind with JSON. You might have used jQuery or something like that to make AJAX calls to a web server. We'll kind of use that analogy to understand how we're using Web3 to talk to the Ethereum blockchain. So right here, I've got, web3js.readthedocs.io pulled up. So if you want to, kind of browse this to read more about Web3.js, you can do that. You can also look at the Web3.js GitHub repository. You can browse these more. So yeah, we're going to be talking about how Web3 can talk to the Ethereum blockchain. And I actually pulled up this blog post that I found when I was doing a little Googling. I'm not actually sure who this is, so if this is your blog, let me know. But this has a pretty good diagram that I want to show you. And this is a pretty good illustration of how, a website can talk to the Ethereum blockchain with Web3. So basically, a website talks to the blockchain with Web3 with something called JSON RPC, which if you pull up the Wikipedia article here, RPC stands for Remote Procedure Call, and it's really Remote Procedure Call Protocol. And this is the method that allows us to talk to the Ethereum blockchain. So, Ethereum is a blockchain, which basically means it's a peer-to-peer network of nodes that all talk to one another. And the blockchain is where all the data and things like that and all the code are stored. These are all the nodes that talk to one another. There's quite a large number of nodes on the main network, Ethereum blockchain. But this is, a kind of representation of that. And essentially, what's going to happen is we use this JSON RPC protocol to make requests to a particular node on the network. And that's going to kind of act like our API in a sense, like that's our analogy to a traditional web development background. And that's going to, represent all the data that's shared across the entire Ethereum blockchain, and it's going to access, the code that's going to be shared across the entire Ethereum blockchain. So essentially, if we want to make a call to a smart contract or read data about an account, we're going to use Web3.js and talk to a particular Ethereum node with, JSON RPC. And that's precisely what we're going to do today, and that's precisely what I'm going to show you how to do. So let's go ahead and take a look at how that works. So there's a few different things that we're going to need in order to complete the tutorial today. The first thing is Node.js, which you can see if you have Node already installed by going to your terminal, typing node-v. And if you don't, you can install it with a command line tool like Homebrew, or you can go to the Node.js website and install it yourself. And the next thing that we need is, we also need the Web3.js library, which I'll walk you through the installation steps for in a second. But the next thing that we'd also need is an Ethereum node. And there's a few different ways that we could, do this. I want to talk to the main Ethereum network today. So, we could do something like, run an Ethereum node locally. That's what I'm doing here. This is Geth. This is an Ethereum node that has been syncing. Looks like I had a little issue here. But we're going to not do that today. I don't want you to have to download, Geth and get that started. I'd rather just show you how to connect to a remote node that, is out there on a server somewhere that you can talk to. So I'm going to show you how to use Infura. So Infura is a way for you to get access to an Ethereum node over JSON RPC very quickly. And you can get started for free by just clicking this button and signing up. I've already signed up, so you will get a screen that looks like this, where you can get a copy of your API key, or you can just copy a link to this URL that you'll use to instantiate a connection for your remote node. And so copy that, and we'll keep that handy, and we'll use that here in a second. So now you can go to your terminal, and once you've got Node installed, you can install the Web3 library with npm. And this is the package manager that comes with Node, like this: npm install Web3. All right, now that that's done, you can open up your Node console by just typing Node. And now what we want to do is actually, start messing around with Web3. So we do that by first requiring the Web3 library. We're going to assign it to a variable. This will say var Web3 equals, we'll say require Web3. And notice this is capitalized. We're going to use a lowercase Web3 here in a second. All right, so let's just type Web3 here and see, kind of what we've got. Now I'm going to browse around for a second and, kind of see what was returned to us. We can see the different things available inside of Web3. We can kind of see some functions that are available. And if you scroll down, you can find this mapping right here. This is pretty interesting. So what this is actually a conversion table. So this shows you the different units of Ether, essentially. The different conversion tables. This is a conversion table that shows you how Ether can be subdivided. And there's other websites, like I think Ether Converter Online is a reference that you can use as well. But this is a way of just kind of seeing how Ether can be divided. So if you look in the middle here, you'll see Ether right here. And this is how many times Ether can be divided. And if you go all the way down, I believe this is the 18th place. This is Way. This is the smallest unit of Ether. This is the unit that's going to be used natively inside of smart contracts. And anytime we read a balance from an account with Web3, we are going to get this value in Way, and we'll have to actually convert it back to Ether, which I'll show you here in a moment. All right, so now let's actually connect Web3 to the blockchain. We'll do that like this. First, we'll go back to Infura, and we'll get the API key. We'll copy that, and we'll say URL equals. We'll paste in our Infura URL here, and now we'll say var Web3 lowercase equals new Web3 uppercase. And we'll paste in that URL. All right. Now let's see what we got here. All right. We can see more functions and properties that are available inside this Web3 object. And there, you could browse around in this pretty much all day and read about the different things that you can do with Web3. But I'll just show you a couple. Today, what we're going to do is actually kind of talk about interacting with accounts with Web3. So if you're coming from a web development background, if we look at that blog post that I showed you earlier, this is the Ethereum network, right? Like, instead of using a web application where, a centralized server would store your account information, like your username and password, when you're using, the Ethereum blockchain and you're using, a website that would talk to the Ethereum blockchain, you have an account, right? But it doesn't live on a server. Your account actually, represents you as a user of the network. It's going to be this really long string of characters that, represents, your user. And that's going to be the same from, web application to web application that talks to the blockchain. It doesn't live on the server. It lives on the blockchain. So what we're going to do today is kind of show you how to, get information about your account, right? So first of all, what we want to do is actually, find an account. And in order to do that, we're going to use a website called Etherscan. So if you're not familiar with Etherscan, it's a very handy tool. So Etherscan is a blockchain explorer, and it essentially allows you to read all kinds of data about the Ethereum blockchain. It allows you to see all the block information, anything with an address. You can read information about it. You can read token balances. You can look up smart contracts, things like that. So what we want to do is actually find an account on Etherscan and start reading data about it. Because we pulled up this Web3 library that's actually connected to the main Ethereum network. Now we can explore on the main Ethereum network and find an account that's connected to the network and read some information about it. So I thought it'd be interesting to go to etherscan.io/accounts and find some pretty rich accounts, maybe a whale, if you will. So let's just take maybe the third largest one here. And click on it. We'll copy the address. And we can see the transaction history here. They've been moving around a lot of Ether lately. Well, this is a long time ago. Let's do a more recent one. Let's do this one. All right, this one's pretty current. So they got about $743 million here. So we'll copy this account address. We'll go back to our client here. Let's say var address, and we'll paste this in. I'm actually going to read the balance of this account. So we'll do that like this. We'll say Web3. We'll say ETH. Now ETH is the object that's going to contain a lot of functions that are going to allow us to interact with Ethereum. If you've used something like Geth before, which you may or may have not used, the Geth console is a JavaScript runtime environment that's going to have a lot of these same kinds of functions. So we'll say web3.eth.getBalance, and we'll pass in the address. And what this is going to do is accept a callback function. And the first argument is going to be an error. And the second argument is going to be a balance. Let's say actually val. I'm going to pass it an arrow function. And what we'll do is we will say, balance equals val. All right. So what we can see here is that I've assigned the balance of this account to a variable. So, this is basically a way that we can read how much Ether is in the account. But this number right here doesn't actually correspond to the amount of Ether, right? It actually corresponds to the amount of Wei, which is kind of what I was showing you earlier. So Wei is the, smallest denomination of Ether. It's kind of like if you divided a US dollar to its smallest amount, you get a penny. That's kind of what Wei is with Ether. So if you go back up to our previous example where I showed you this table, and you can see, Wei is down here and Ether is here. or sorry, here. So what we can do is actually convert this to Ether with a utility. So Web3 has a utils namespace. So, we did web3.eth a minute ago. Now we can do web3.utils. And we can say from way, right? So we want to convert a unit from way. We can say, the balance. And we can tell it, what we want to convert it to. We can say Ether. Boom, there we go. So this is the amount of Ether that's in the account that we just copied from the main Ethereum network. And if you pull up Etherscan, you can see that this number is the same. It's 1.3 million. Yeah, 1.3 million Ether, which currently looks like, $750 million. It's a lot. So yeah, you can also convert this to other stuff, like I believe Gwei is an option. Yeah. So Gwei is, another subdivision of Ether. It's a larger, factor of Wei. You can see it here. You'll see Gwei a lot when you're calculating gas on the Ethereum network. Probably capital G is what we actually want. Let's see this. Yeah, there you go. All right, so that's how you can read data from an account with the Web3 library. And something else I can show you now while we're here is you can actually create an account with Web3. So, when you're using the Ethereum blockchain, like I said, when you have an account or an address, right, like that's your, user of the entire network. And, this string that I pasted here earlier is your address, which is a representation of your public key. And there's also something called a private key, which is kind of like your password in a sense. Basically, it's something that gets run through a hashing function to represent your public key. And this is actually a subset of that. So what I'm about to show you is going to reveal your private key. So I don't really recommend that you do this. This isn't the best way of doing this, but I just wanted to show you that you can do it. So you can actually create an account with Web3 like this. So you can say, web3.eth.accounts, create, call it a function. And there you go. You have a brand new account on the Ethereum blockchain. And this is on the main network. So if you're watching this, do not use this account because anyone who's ever seen this video will know the private key, which is essentially your password. So if you're going to use this and store any amount of Ether, they could steal it. So don't do that. But that's how you would do this with Web3. And there's lots of better ways, but I just wanted to show you the capability at the moment. And while we're here, just as a bonus, we're talking about connecting to the main Ethereum network, to a Ethereum node with JSON RPC. And I wanted to show you how you can connect to, a local private Ethereum network for your, own development purposes with Web3 if you wanted to do that. If you wanted to deploy a smart contract to a local private blockchain or something like that, you may want to connect to a blockchain locally. Now, like I said earlier, you can do that with Geth. But instead of showing you how to get started with Geth, it can be complicated and daunting, for the first time user. So I'm going to show you how to do it with Ganache or Test RPC, which it used to be called. You can run this via the command line, or you can run it with this GUI. You might have seen some of my other tutorials where I show you how to use Ganache. So Ganache is basically a private in-memory blockchain. Works a little bit differently than Geth, but it does pretty well for development purposes. So basically, it shows you right here, the RPC server address. This is essentially localhost, port 7545. And, we can copy this and connect to Web3 client, connect to it with a Web3 client. So we'll open back our node console and we'll say, same thing we did earlier. We said, var web3 equals require web3, and we'll, create a new connection. Var web3 equals new web3 HTTP, paste that in. and do this. All right. And then what we can do is say, open Ganache back up. We can take this address right here and copy it. And we'll just say web3 eth.getBalance. We'll pass in that address. And we'll pass it the callback function. We'll say, we'll call this way. And we'll say web3.utils.fromWay. And pass in the way. And say ether. And we'll, I think I got that right. Oops. I made a little error here, guys. Sorry, a typo. This will be web3.utils. Oops, almost, guys. Let's see, balance. All right, let's see what the balance is. Boom, there we go, 100, which is exactly what this reads in Ganache. So 100 ETH. So this video is, designed to teach you how to use Web3.js, which is, one half of the equation when you're developing decentralized applications. There's smart contract development, which is code that's going to get written and deployed to the Ethereum blockchain. And the other half of the equation is interacting with those smart contracts with JavaScript with some sort of client. And that's what we're talking about today. So today we're going to use Web3 to create, a way to talk to a smart contract. And we're going to read some data from the contract and, kind of see how you can do that. So if you look at this documentation here, this is web3js.readthedocs.io. This is how we're going to actually, create a way for Web3 to talk to a smart contract. It does this with this web3.eth contract here. And essentially what this does is it creates an abstraction of our smart contract in JavaScript that we can use to, call the functions of the smart contract. Now, smart contracts are written in Solidity on the Ethereum blockchain, which is, a completely different programming language than, JavaScript, obviously. And they get compiled down to bytecode that's executed on the Ethereum virtual machine. And, if we want to actually be able to, interact with that smart contract on the Ethereum virtual machine on an Ethereum node, we must know, the interface of the contract. We must know what kinds of functions it actually has, and we must know, what functions we can call and what we can actually do with it. And that's exactly what we'll do with this, ETH contract here. We're going to create, a representation of the contract in JavaScript, and we will, use its functions. And we'll do that like this. So let's just kind of look at this documentation here for a second. What we're going to do is create a new Web3 ETH contract. And this is saying that we need to give it a JSON interface and an address. And these are the two kind of components that are critical. So a second ago, I said, we need to know what the interface of the contracts looks like. We need to know what kind of functions it has. And so essentially what we can do is get something called an ABI. Now, an ABI is essentially just like a JSON file that tells you what a smart contract can do. It's going to show you all the functions that it has. It's going to show you lots of different information about it. So I'll show you an example. You can actually look at this here. So here's an example of a contract ABI. It has some information about the smart contract. This is called election. This is actually a representation of a smart contract that I actually built out in a longer tutorial that I have on this channel, where I show you how to build your first decentralized application on the Ethereum blockchain. You can check out that video if you'd like. And so this is, a JavaScript JSON representation of the smart contract that shows you, the kinds of things that it responds to. Shows you the bytecode for the contract. So I don't want to get too bogged down in this. I just want to show you that this exists. And this is, like the Solidity code that corresponds to the JSON ABI. I teach you how to build this Solidity code in my other tutorial if you want to check that out. All right, so that's the first thing. So we need a smart contract ABI when we actually want to talk to a smart contract on the Ethereum blockchain. We need that big old JSON file that I showed you a second ago. And we also need to know where the contract is located. We need an address. So if you're new to Ethereum development, and you checked out maybe the previous video in this playlist, everything that's connected to Ethereum has an address. So you as a user that's connected to the Ethereum blockchain, you have an address that represents your account. And also smart contracts that are deployed to the Ethereum blockchain also have addresses. And this just basically tells you, where the smart contract is located. And that's essentially what we need here. In addition to the interface that tells us how the smart contract works, we need an address to tell us where the smart contract lives. So we'll get both of these pieces of information whenever we create this new smart contract in JavaScript to interact with. And what I'm going to do is connect to the main Ethereum network, and we're going to actually read a smart contract that is deployed to the main Ethereum network and read some real live data to show you how that works. And also I should note that, if you watch my previous video, I kind of compared, talking to the Ethereum blockchain and the smart contracts on the blockchain and all the nodes on the Ethereum network. I kind of compared that to like talking to, API maybe, like if you were coming from a traditional web development background where you have, a JavaScript client that wants to talk to an API in a similar way. We're going to use, a JavaScript environment to talk to smart contracts on the blockchain. The blockchain is going to be essentially our back end in this case. So we're going to try to, call some functions that might be kind of like endpoints on a back end or something like that. It's not a perfect analogy, but it gives you an idea of what we're going to do. And what we're going to do is actually talk to a token contract on the main Ethereum blockchain. We're going to talk to, a token that was, minted and went through an ICO, and basically distributed across the blockchain. So Ethereum has a way to implement tokens with the ERC20 standard. ERC20 is just a standard that specifies how the tokens work, and it specifies a common interface so that all the tokens work the same way, so they can be like listed on exchanges and bought and sold that way and transfer between wallets in a predictable fashion. And this is called the ERC20 standard. You can read more about this if you'd like. I go into this more in depth in some of my other videos where I show you how to build an ERC20 token. And you can see that there's some functions this token responds to, like the name. You can read the token's name. You can read the token's symbol, like you'd see on a cryptocurrency exchange. You can read the total supply of the tokens, and you can read the balance of somebody who owns the tokens. And these are some of the kinds of functions that we'll run through today whenever we interact with this smart contract with Web3.js. So let's go ahead and get started. First, you want to go to your terminal, and you want to ensure that you have Node.js installed. You can check that by going node-v. And you also want to ensure that you have the Web3.js library. You can install that with npm install web3. I've already done this, so I'm not going to do it again. Once you've completed both of those steps, we'll go ahead and open the Node console like this. Just type node and enter. And the first thing we want to do is require the Web3 library. We'll do this with uppercase var web3 equals require web3. All right. And what we want to do now is get an actual instance of web3. We say var web3 equals new capital web3. This is lowercase, this is capital. And what we need to do is pass it a URL for an Ethereum node. Now, I talk about this more in depth in previous videos, so check that out. I don't want to belabor the point in every video, but essentially what I'm doing is creating a connection to the blockchain, and you'll need a URL for an Ethereum node. You can run one locally, or you can use a remote node with something like Infura. So check out that first video if you want a greater explanation of what's going on here. All right, now let's just ensure that our connection worked. We can kind of see, yeah. Looks good to me. All right, so what we want to do is actually, create an instance of this smart contract in Web3. We want to create a JavaScript representation of that. And, a moment ago, I said that we need, the smart contract ABI and we need an address. And what we want to do is actually, read a smart contract on the main Ethereum network. We want to read a token. So let's go find a token that we can actually use and interact with. So what I'm going to do is pull up Etherscan. So Etherscan is a blockchain explorer that lets you, read all kinds of data on the Ethereum blockchain. You can find smart contracts and, accounts and look at transaction histories and blocks and things like that. So I'm going to find a real token by going to this Tokens tab and going to View Tokens. We'll choose a pretty popular token. Let's say OMG. So I'll click on OMG here. And, like I said, these tokens are smart contracts that are written with this ERC20 standard that I mentioned a moment ago. And what I can do is I can actually get some information about this on Etherscan because it's publicly available. I can essentially click on the contract address here, and it's going to give me a way to look at the code of the smart contract. I can actually see the Solidity code here that implements this ERC20 interface. And I can also get this smart contract ABI, which is the thing I talked about a minute ago. This is going to tell Web3 what the contract does. So I'm going to copy this, and I'm going to go back to my terminal. And I'm going to say ABI, or var ABI, equals this ABI. So I'm going to just paste it in. Hit enter, ABI. All right, so this actually gave us the JSON. We can see that was formatted nicely for us, so we can tell what's going on. Again, if you look at this ABI, you can see that these are names of functions. Name, it's a function. It tells you right there the type. This is the total supply, which is also a function. You can see that there. You can see, mint, paused, balance of. That's one we'll use in a moment. This is also a function. So that kind of just shows you what's happening with this ABI. Now we want to tell Web3 we need the address. And that's pretty easy. We can just go up here to this address and click copy and go back to our terminal and say var address. Paste this in. All right. Now that we have both those things, we can read some information about this. Actually, let's rename this variable. Let's say contract address, because what we want to do is get a account address momentarily. Yeah, oops, looks like I had a little typo there. My fault. So yeah, what we can do is get a connection to the smart contract with Web3. So we'll do that like this. We'll say is var contract is going to equal, let's be new web3.eth.contract, and we'll paste in the ABI that we stored to the variable in the terminal. And we're also going to pass it the address. This will be the contract address. Oops. Looks like I put too many S's on the last end of that last one. That was why. Okay. Now we can see that we've got an instance of this contract. And we know we do because we can say, we can actually call a function on it. What we'll do is see if we can get the name. We'll do that like this. Tract methods. We can actually see the list of the methods that were created by the ABI. The ABI basically told us what functions this contract responds to. So we'll actually see that it responds to name. This will give us the name of the token. We could say methods name, and this is actually going to just return the actual function that is name. It's not going to call the function. So we must call it like this. We must say call. And in order to get the value, if we, this is just going to return a promise. This won't actually return the value because this is an asynchronous call. So in order to actually read the value, we must pass it a callback function. And we do that like this. We just pass it a function. Just sketch this out. And it's got a couple of arguments. The first argument is an error. And the second argument is the result. And let's just console log the result. We'll say result. All right, there we go. We can see the contract name was actually returned to us. This is OMG token. This is the actual OMG ERC20 token that you see all over the place, bought and sold on cryptocurrency exchanges, listed in coinmarketcap.com. We're actually talking to this token on the Ethereum blockchain, and we've just read the name. We can also see, some other things that we can do. Track methods. These are the other, functions that exist in the smart contract provided by the ABI. Let's just say, let's read some more data. We can say, you can see the symbol right here. This will be like, what's on the cryptocurrency exchange. Let's just edit this. All right, OMG is the symbol. And let's also look at the, let's see here. Let's look at the total supply. This is going to tell us, how many OMG tokens actually exist. Let's say, boom, there you go. That's a really big number. We can also say, I believe you can see if minting is finished to see if all the tokens have actually been minted. I believe I saw that somewhere. Yeah, minting finished. Yep, it's true. So all the tokens have actually been minted and the supply won't change. So now what we want to do is actually read some more specific information from this contract. ERC20 tokens allow you to read the balance of people who hold specific tokens, and that's what we'll do next. We'll essentially, we're going to create, we're going to do balance of. We're going to call this function. This exists. This is a balance of right here. This is a function that allows you to read the balance of someone who owns it. And essentially, this is going to take an address, which we can see here. We can see the list of arguments that these functions accept whenever you call methods. So balance of address, right? And we say contract methods balance of. So we need to actually paste the address in. So I'm going to hit enter, but this is not going to work. All right, it's going to give us an error. It says invalid number of parameters. So we need to give it an address. So what we want to do is assign an address to someone who holds these tokens. So we'll say var account address. We'll actually need to paste an address in here. So how do we find an address? How do we find someone who holds these OMG tokens? Well, if you hold OMG tokens, you could put your own address in there, or I could put my own address in there. But for this example's sake, let's find someone who owns OMG. So go back to Etherscan and find this page that shows you the smart contract. And I'm going to go back to the token page, and the token page is actually going to show us as a tab that shows you token holders. And this is, I believe, ranked by quantity and percentage. You can see the percentages of people who own these tokens. So let's click on one of these. Let's just click this address here. We'll see who this is. So it looks like this is actually a smart contract. Yeah. So one thing to notice is that, like I said, smart contracts have addresses and accounts have addresses on the Ethereum blockchain. And, you and I, as users of the Ethereum blockchain, can hold tokens, but so can smart contracts. And that's exactly what is going on here, I believe. It looks like this is a holder, but it's a smart contract. And I'm going to copy this address and minimize this. So this is technically an account. It's just a contract account. And what I'm going to do is type in balance of address. All right, there we go. And we can see the balance of how many tokens this particular account actually holds, which is a lot of tokens. If you go back to Etherscan, you can actually see what that's worth. Looks like, $41 million. So it's a lot. All right, so that's an overview of how you can use the Web3.js library to talk to smart contracts on the Ethereum blockchain. And today, we talked about how you can read data from smart contracts. You can do a lot more with the Web3.js library, like, actually writing data to smart contracts on the Ethereum blockchain. You can, deploy smart contracts. You can do things like that. And yeah, you can compile smart contracts and do all kinds of stuff. So let's go back to this kind of project template that I've been using throughout this tutorial series. I basically have just an app.js file here and a terminal where I'm going to run this with Node. So make sure you've got Node installed. Just go to your terminal, type node-v, check. And you want to make sure you had the Web3 library installed. You can do npm install Web3, like that. So I've got, this is boilerplate code here with this app.js file. And what I've done is just required the Web3 library from Node and from Node Package Manager. And I have created a new Web3 instance with an Ethereum remote node URL from Infura. And I'll show you how to set that up in the previous videos, so check that out if you're unfamiliar. The big picture is that you just need a link from Infura. You can sign up to get one of these, and I'm connected to the main Ethereum blockchain. So what we're going to do is kind of just walk you through some cool tips for Web3. So the first thing I want to show you is Web3's got a cool way where you can actually get the kind of average gas price on the network. So you do that like this. Web3.eth.get gas price. And we will just console log this. Okay. Run this. Oops. All right, we can see this value, and we could actually log this like this and say results. And we can use more Web3 utilities to convert this value to Ether. From as utils, actually. And we can say results, say Ether. See if that works. Oh, I got to console log this. All right, it's a pretty small amount. That's the average gas price expressed in Wei, which is the smallest denomination of Ether, kind of like a really small penny, from the last few blocks. And it basically calculates the median gas price in order to show you that number. So that's a pretty cool thing you can use whenever you're trying to calculate the gas price currently for the network. Now, the next thing I'll show you is how you can have access to hashing functions with Web3. You can use SHA-3 like this, 3 utils SHA-3. This is a hashing function that we can use, and we can say Dapp University. Let's just see what happens here. Oh, sorry, I want a console log. All right, so you can see the hash value there. And there's a couple different things you should know about this. If you want to hash, like a number, you can do it like this. You need to wrap it in a string. because if you do it with a raw integer like this, it won't work. All right. So it needs to be wrapped in a string in order to run the hashing function, or you can use a big number. Oops, sorry, I don't have this pulled in actually. Yeah, I would just use a string. So one thing to know is that you can, if you're going to do a hex value like this, it also has to be inside of a string. You can't just do it raw. It won't work. Okay. This also has an alias, kcac256. I believe. I think that's right. Yeah. I always have a hard time spelling this. Yeah, it looks like I just had a typo. Sorry, I always misspell this thing. But yeah, that's the alias, is kcac256. And that just does the same thing. So you can see 3. See, the result's the same. And so Web3, important to know that Web3 will generate a SHA a little differently than Solidity will. And Web3 gives you access to the Solidity SHA-3 hashing function. Say Solidity SHA-3. Now, the reason to know about this is because it's going to calculate, the SHA-3 of the input parameters the same way Solidity would, which basically means that the arguments, they'll be ABI converted, and they're going to be tightly packed before they're actually hashed, which works a little differently than how Web3 does it. So another thing that you can look at is we can get access to a little bit of randomness. We can say like this. You can say web3.utils random hex, and we can pass in the length that we want. All right. And we can also pass in 0. All right. And we can pass in 32. Okay. So another really useful thing, and this is a nice little gem if you're kind of trying to debug things in the console. One of the things that always frustrates me about JavaScript is that it doesn't really have much of a standard library to speak of. And if you're coming from a language that has a lot of rich features, and sometimes JavaScript leaves a little bit to be desired, and I understand why. I mean, footprint really matters with JavaScript because it's designed primarily to run in your browser. And, we always have to worry about, how many features we have in a language like that. You don't want a really heavy footprint in the browser, so I understand. But sometimes, you always find yourself pulling in libraries to handle things. And one thing that Web3 ships with is _JS, which is a little known fact. So you can get access to the underscore library like this. You can say... I don't know if this will let me do this. Let's try this. Let's try this. Web3 utils. Well, first of all, let's just log this. Just to prove that it's there. All right. We can see all of the functions that are in the underscore library. If you're not familiar with it, I'll just show you. So, underscore JS is a library that has a lot of nice functions that allow you to do things you can't really do natively in JavaScript, or maybe some cleaner ways to do things, or just extend your JavaScript development experience. So instead of pulling that in with Node, you can have access to it. Sometimes this is helpful when you're debugging things in the console with Web3 and you want to use something like an underscore function. So for example, let's see if we can do this. It may have a naming conflict. Equals, we'll see if this works. Oh, it worked, okay. So let's say, for example, something you can do in underscore is say, we can use each, and we can map over an object. Let's just say key 1. We'll say value 1. And key 2, value 2. And we can pass this function. And we can say console log key. I believe the order is value key. I think so. Let's just see. Yep, I got it right. So you could basically pluck off the keys from an object and iterate over it and just have access to the key value pairs. So that's like an example of something you can do with underscore JS. And now you know that you have it handy, prepackaged for you with Web3. So, it's an example of a few things that we can do with, Web3. And I'll kind of just show you more of the documentation with Web3. We can kind of pull this down here and say, I wanted to just kind of leave you with this because this is probably going to be the last video in this series that I do, unless there's something else you all are sure that you want to see. Just notice that there's different, modules in here we looked at. We looked at the ETH or ETH modules and saw a lot of things in there. You can do other things like the subscribe module. This is what allows you to subscribe to specific events on the blockchain, which is pretty cool. Allows you to listen to certain things. You can subscribe to syncing. If you're syncing a Geth node, you can always see if that's doing anything. We used contract when we were interacting with a contract. We used accounts when we were interacting with accounts. We were, doing things like that. There's personal. This is what you would use like with the the Ethereum nodes accounts, like if you're using Geth as the personal library. We kind of stayed away from that because I was trying to showing you how to use Web3 within Fura remotely rather than interacting with Geth. So we didn't do much with the personal library. But just as a general explanation, an Ethereum node can basically have accounts. And like if you're running Geth locally, you can, keep track of your accounts with the personal library. Let's see some other things. So one thing to notice here is this SHH. This is the library for interacting with Whisper. So if you're not familiar with Whisper, Whisper is basically a protocol for like broadcasting messages across the network, and it's kind of devised for a communication protocol between dApps. But I know people are using it to create like chatting applications and things like that. So that's what Whisper is, and this is the part of Web3 that allows you to interact with Whisper protocol. And if you want to read more about that, you can just all right. So whenever we are deploying a smart contract, to the Ethereum blockchain, we are creating a transaction. And that's important to know, right? So whenever we create a transaction on the Ethereum blockchain, we're writing data to the blockchain. We have to pay a gas cost, and it creates a transaction. It creates a record on the blockchain that, is there forever, right? It's a transaction that's written to the blockchain. Whenever we create a smart contract, on the blockchain, we deploy it, we write this transaction, and the contract is now there forever. So today I'm going to show you how to do that with Web3.js library. And there are a few ways to do this. You can deploy a smart contract with some nice Web3 utilities. If you have access to a Geth node where you have personal account information and things like that, you can use the personal object, the personal library inside of Web3 to deploy a smart contract. But I'm actually going to do this like the most manual kind of way to show you how these transactions actually work, right? I'm actually going to create a raw transaction that deploys the smart contract data, and it's going to sign the transaction with a private key, and we're going to broadcast that transaction to the network and deploy the smart contract. So this is going to be a very similar example to the last video where I showed you how to create a raw transaction with Ethereum. So check out that previous video if you haven't already. This is going to build pretty heavily upon that implementation. So I've got some boilerplate code set up here. You'll of course need all these dependencies, which you've used in every other video in this series so far. You'll need this Ethereum.js TX library. You can just install this with Node Package Manager. You'll need the Web3 library, which can also be installed with Node Package Manager. And you'll need an Infura link. This is going to be an RPC connection to a remote node hosted by Infura on the Ropsten test network. We're going to be using the Ropsten test network today. And you'll need at least one account. I'm going to go ahead and kill this second account because we don't need that. All right, so you'll need the account's address, and you'll need its private key so that we can sign the transaction. I've hidden my private key off screen here with an environmental variable. I showed you how to do this in the last video. You don't have to do this. It's just safer, and I don't want to show you my private key, so that's why I've done this here. And we want to convert this private key to a buffer that can be used by this Ethereum.js transaction library. All right, so in the last video, if you remember, basically what we did was we created a we created a transaction object, and then we basically signed the transaction, and then we broadcast the transaction. All right. And I'm just going to paste in some of this code from the last example. If you want a more in-depth explanation of what's going on here, be sure to check out the previous video. So yeah, this is how we broadcast the transaction. This is how we sign the transaction. And this is how we're going to basically create the transaction here. We'll say const tx object. And this is going to take some values. Nonce, the gas limit, gas price, and the data. Okay, and we get the nonce value by getting the transaction count by getting the actual transaction count from the account that's going to broadcast the transaction. And we'll wrap all this inside this callback function like this. Again, if this is too fast and over your head, check out the previous video where I explain kind of everything I'm doing here in depth. I don't want to have to reiterate this in every single video, just in case someone's already seen the other video. I don't want to bore them. So just another high-level overview is we're creating this transaction object, that's going to actually get, broadcast to the network. We're signing it with this this library here, and then we are actually broadcasting the transaction to the network with web3.eth.send signed transaction. It's going to accept this raw transaction that we created, and we'll get the data here. So the values that we're sending for this transaction are going to be, web3, utils, 2 hex. Remember, all of the values inside this raw transaction object need to be in hexadecimal, so we need to convert the transaction count. 2 hexadecimal, we're getting that here from the value that we're injecting with this callback function when we're getting the transaction count of account 1. Remember, the nonce is just the number of transactions that the account has already written. To prevent the double spend problem, we need that whenever we're creating a transaction object. And the gas limit is going to be the maximum amount of gas that we have to spend in order to create this transaction. So let's say web3.utils.2hex, and we'll use a pretty high transaction. Let's do 1 million units. And we'll say the gas price is going to be web3.utils 2hex. We'll say web3.utils two-way. We'll pass in 10 Gwei. All right, so I should mention that deploying a contract is going to send some data to the Ethereum blockchain, which is going to cost a lot more gas than just like sending Ether back and forth. So we must raise this amount. Let's say raise this. This is a lot more than 21,000 units of gas, I believe, is what we used to create an Ethereum transaction to send Ether back and forth. Now, why am I doing this? So I'm doing this to show you that when you deploy a contract to the Ethereum blockchain, you're creating a transaction, and you can do this like you can assemble all these pieces yourself like this to see how a transaction works. So when we are creating this transaction object, like almost forget about all the individual pieces of what's going on down here. Just notice that this is what sends the transaction to the network. This is what signs the transaction to tell us that, hey, it's this account that's trying to do this. And then this is the actual data that gets sent, right? So don't worry about all the details necessarily if you don't understand it. This is just the data. This is just telling us who sent it with a signature or kind of like a password. And then this is the actual sending of the data. So the reason I'm showing you this is to show you that you can create a smart contract by creating a transaction like this. And essentially what you do is you send the data, the actual byte code of the smart contract that's going to get executed on the Ethereum virtual machine with this data field here. And notice there's no to field, like there's no to. Like normally if you're going to send Ether, this would be an address, right? We don't need that because we're sending this we're broadcasting this transaction to the entire network. There's no specific recipient. And that's what happens here whenever we deploy a smart contract. We are broadcasting a transaction to the entire network and saying, hey, here's the data that we are trying to broadcast. And this data is going to be basically code of the smart contract. All right, so in order to do that, we need to fill in this data. For now, we'll just say data. And we'll actually need to get the smart contract data. We'll say const data. We'll pass it a string. Now, how do we get this data? How do we actually get data for a smart contract that we want to broadcast to the network? Well, we need a couple of things. We need to basically compile this smart contract down into bytecode, and we need to get some data that this is going to understand, that the blockchain expects. And before that, we also need a smart contract. We need some code that is going to get deployed to the Ethereum blockchain. And I'll show you kind of all that. So let's open up Remix. This is remix.ethereum.org. This is a browser-based IDE put out by the Ethereum Ethereum, and basically allows you to keep a list of files that you can save, smart contracts that you can compile or run and deploy. So what I've got here is a smart contract that I built in some of my previous tutorials. I have a pretty long series called Code Your Own Cryptocurrency on Ethereum, where I show you how to build an ERC20 token. So you can check that out if you're interested. I also show you how to build like an ICO website and a crowd sale, things like that. So check out that video if you're interested. But this is, the token contract that we actually build in that video. This is an ERC20 compliant smart contract. So you can, copy this code if you'd like, or you can really get kind of any ERC20 token code if you'd like to, and deploy this to the blockchain. I should probably put a link to this down in the description below, or if you're watching this video on my website, I'll put, this code below the video. So you're going to need the smart contract inside Remix, which I've pasted here. And what we want to do is actually start to compile this thing, and we'll click on the Details tab. And this is going to give us some information that we can work with. We can see a lot of different things when we've compiled this. We can see the bytecode here, and the ABI, and some instructions that say, hey, if you want to deploy this contract with Web3, here's how you do it. Now, remember I said Web3 kind of gives you some ways to do this if you have access to, the personal object inside of Geth, the personal library inside of Geth, or if you're doing this on the web and you actually have the ability to use something like MetaMask to sign transactions, right? You can do that. But if you don't, and you want to do this without trusting a node, we're going to do it our way, which is to build a transaction manually. And so I'm going to, this basically tells us the data that we need to send inside that transaction here. So what this is just the compiled down bytecode converted into the hexadecimal value that we need. So let's copy this and go back to our project. Basically going to just paste this in here. It's going to take a second because this string's really long. I'm going to copy this string out and delete all this junk. And I'm going to paste the data inside this long string here. All right. So save that. I'm going to minimize the window here. And now I'm going to actually, create this smart contract on the Ropsten test network. So here's the data. It's going to get filled out in this transaction object here. Here's the gas price. Here's the gas limit. And here is the nonce, which is, the transaction count for this smart contract, or sorry, for this account, right? And remember, so basically this is building the transaction object. This is signing the transaction with this Ethereum JS TX library. And then this is actually using the Web3 library to broadcast this raw transaction, which is the whole point. This is building a signed raw transaction, and then send signed transaction. So essentially, sign raw transaction and then send signed transaction. And we're going to console log any errors that might happen. And if it's successful, we'll log the transaction hash, and we'll actually go visit this smart contract on the on Etherscan. So let's give this a try. Again, this is just an app.js file that I've created inside this directory, and we can run this file like this, just a node app.js. All right, looks like I have a syntax error here. I forgot a parenthesis, I believe. All right, so it looks like it worked. Let's see. I mean, there could be a couple of issues. There could be, I don't know if the gas limit was high enough. It's not a guarantee that this worked. It broadcast a transaction, but let's actually see if it wrote it. So I'm going to go to Etherscan. Again, I'm going to go to Ropsten.etherscan to make sure I'm looking at the Ropsten test network. Paste in the transaction hash, and let's see if it worked. I'm not going to guarantee that it did, but let's find out. All right, so it's pending. You can see that this is contract creation, right? This is the to value. Like I said, we don't actually want to send this to an address. We want to send it to the entire network, and it knows that this is a contract. You can see the input data that we filled out here. You can see the, all this other data that we filled out, right? Here's the transaction has to be searched by, and boom, look, it was successful. Yeah, we can see this contract was actually created on Ropsten Etherscan, or actually on the Ropsten network, but Etherscan now knows about it. We can click on it, and we can see the contract address. We can see the contract creator. This is the same address that we have been using in this tutorial. We can see all these different values. And yeah, let's copy this smart contract address and actually, try to interact with it like we did in the previous tutorials. So I'm going to comment out all this stuff. I don't want to create any more smart contracts. I'll just say this is the contract address. Say const. All right. And what I'm going to do is actually I want to try to interact with this. So I want to get a copy of this smart contract from the blockchain and try to read some data out of it to see if we can pull it back with our connection here. So the other thing that I need is the contract ABI, which is available in Remix, right? We compiled this down and it shows you this contract ABI here. Let's just copy this again and paste it here. All right. So what I'm going to do is actually take this out, copy this ABI, take it away, and say const contract ABI. Oops. Do that. And then I'll say Dapp token contract is web3.eth.contract. And I'm going to pass in the ABI, contract ABI, contract ABI. I believe that's right, yeah. And then contract address. And yeah, I'll do that. And then let's just console log the contract first. See what happens. Minimize this, clear out some of the noise. Node.js. All right, we had a little problem here. Web3.eth.contract is not a function. Sorry, this needs to be capitalized. Oh, sorry. I need to do this. Sorry, guys. Okay, so we can see that we at least instantiated this contract correctly with Web3. You can check out the previous videos in this series where I show you, how to do this manually. But here's an example of how to create an abstraction of this contract in JavaScript with Web3. And now what we want to do is try to read the name of this contract that was deployed to the network. And we can say, let's say, Dapp token contract, methods, say name, say call. This would be an error, and then this would be the result. You pass it a function. Let's see what happens. Boom, there we go. We got the name of the smart contract back from the Ropsten test network. We can also check out, let's see, a symbol. And we can see the total supply. All right, we can also see balance of the account that deployed it, which should have all the tokens. Oops. There we go. We can see how many tokens that this account actually has. It has 1 million. All right, guys. So that's that's an example of how you deploy a smart contract manually to the Ethereum blockchain with the Web3 library without having access to like Geth's personal library, or without doing this via the web, or without having to trust the node, without having to run your own node, things like that. This is how you can just sign a transaction with a private key and generate a raw transaction, sign it, and broadcast it to the network. And just remember that whenever you're creating a smart contract on the Ethereum blockchain, you're creating, a contract like this, or you're creating a transaction like this, and you're just sending, it's compiled down data in hexadecimal. So if you've seen the previous videos, you've seen, a lot of the prerequisites to setting up this little example. Basically what I'm going to do is create a, app.js file over here. And I'm going to, run a terminal process over here. Basically going to just write some JavaScript here and run it inside my terminal. And I'm going to paste in some kind of boilerplate code that is going to get us started. So what we want to do is paste in some of this here. And I'll just go over, what I've imported. So this is a few dependencies. First of all, this is the Ethereum.js transaction library, which you can install that if you don't already with Node Package Manager. You do npm install and then type this package name. Same thing for Web3. If you don't have that already, just install Web3 like this. And this couple lines of code are just setting up a Web3 connection with this remote Infura node. This is the Ropsten test network, and this is the Infura API key. So just check out the previous videos in this series where I explain this more in depth and kind of what we're doing here. You'll need 2 accounts, and you'll need each of their private keys. You can paste their private keys in here if you want to. I am hiding them from you off screen with environment variables, and I'm just reading them with a node like this with process.env and reading the private key 1 and private key 2. So that's kind of our scenario set up. So let's talk about what we're going to do today. In the previous videos, the last 2 videos at least, I've talked a lot about Ethereum transactions and kind of what goes into creating a transaction. We basically have to, create some sort of transaction object. And we have to, sign the transaction. We create the transaction object and turn it into a raw transaction. Then we sign the raw transaction, and then we broadcast transaction to the network, right? And the previous video, like the first thing we did was we just created a transaction that sent Ether, from one account to another. So basically, we just sent, 1 Ether from this account to this account by creating a transaction, signing it, and then sending it. The video after that, we actually deployed a smart contract to the blockchain by sending a transaction. And remember, that's important to know. Anytime you're writing data to the blockchain, you're creating a transaction. When you're deploying a smart contract to the blockchain, you're creating a transaction, and you can, send a smart contract to the blockchain by creating a transaction that sends data to the entire network, and that data is going to be the smart contract, code that's compiled down into a way that the network can understand. So another thing that we can do whenever we're creating transactions is we can call smart contract functions that write data to the blockchain. Now, this course is kind of designed to talk about, Web3. But if you're developing a smart contract, there's 2 different types of functions, on one sense. There's functions that read data from the blockchain, which are free. They just read data. They don't cost any gas. And there's functions that write data that do cost gas, and they actually create transactions, right? So whenever we call those functions, we want to generate a transaction, and that's exactly what we're going to do here today. And I'll show you how to do that. We're going to do this kind of on a very manual way. I'm just going to paste in some code that we used in the previous tutorials. And if you want a deeper explanation of this code, you can check those out. This is the code to actually send the transaction to the network. This is from Web3. This is web3.eth.send sign a transaction. And then this is the code that we'll use. This Ethereum.js transaction library to convert it to a raw transaction and actually sign it. And we'll need to create the transaction object that's going to get converted to a raw transaction object that's going to get signed and then broadcast to the network. So we'll say const tx object. All right. So yeah, it's kind of high level what we're doing. And if you don't understand this code, don't worry. You can check it out in the previous videos. And you don't even necessarily have to understand every detail of it right now to kind of follow along. I would suggest just kind of watching what happens and get the concept and then maybe try to write the code yourself after. So we'll start backwards. This is Web3 library. This is just sending a signed transaction. So we need a raw signed transaction. And that's what we built here. This is basically going to convert this transaction object that we're going to build into a raw transaction that can get, or it signs a transaction first and then serializes it to a raw signed transaction, and then it's going to get broadcast whenever we send signed transaction with Web3. So there's a few values that we need here. We need the nonce, and the gas limit, and the gas price, 2, and then data. Okay, and also I should mention that we're doing this because we want to do this in a way where we don't have access to Geth locally, right? We don't want to run an Ethereum node and use personal accounts, and we don't want to use personal accounts on this remote node that we might not trust. And this isn't, inside of a website or anything where we could use MetaMask to sign the transactions. We don't have that capability. So that's kind of why I'm doing this here. And it's kind of a dual purpose, is to show you that. And it's also to show you kind of what actually goes into creating an Ethereum transaction. And specifically in this episode, how we're going to do that by calling smart contract functions. Okay, so what we really need to do is just fill out this data for the transaction in this example. The first value we need is the nonce. So the nonce is the number of transactions that have already, the number of transactions this account has already sent. So we can get the nonce value like this. We'll say account 1, web3.eth get transaction account by account 1. This is going to accept a callback function with an error in the transaction count. And I'm going to nest all of this inside here and close this callback function. Okay. That should be everything we need. And we need to fill this out. So we have the transaction count, and we need to convert it to hexadecimal, which we've done in all the previous tutorials. We say web3.utils.tohex and pass in the tx count. All right. Now all these values here need to be expressed in hexadecimal. We'll do the gas limit. We'll say web3.utils.tohex. We'll say, let's do 100,000. It might be high, but this works for a tutorial example. Actually, it is pretty high, but we'll just do that for now. web3.utils.tohex. Web3.utils two-way. Remember, all the ether values need to be expressed in way whenever we're creating these transactions. We'll say 10. We'll say way. Remember, gas. The amount of actual gas is calculated by the gas price and the gas gas usage, and the gas limits. The maximum, so we don't overspend. And so the real question is, whenever we're generating a transaction and whenever we're calling a smart contract function that writes a transaction to the blockchain, the question is, where do we send this, and what's the data? We already know who it's going to be from because we're signing the transaction here with our private key. The network's going to know that it was us. That the network's going to know that it was this account because we're signing it with this account's private key. We don't have to fill out the from field. But where are we sending this, and what's the data? Well, you might have guessed that the to recipient is actually the smart contract's address, right? And the data is actually going to be, well, I'll explain that in a minute. First, let's say the contract address. So we need to know where we can send this to, all right? So in the previous video, we created an ERC20 token with Remix and compiled it and deployed it to Ropsten Etherscan the Ropsten test network. But we showed it on Etherscan, and I've still got that pulled up. So I'm going to copy this smart contract code, the smart contract address. I don't know if this copy link actually works. So I'll say contract address. Paste this in here. And we'll use that like this, contract. This is going to be a contract that's actually deployed to the Ropsten, test network, which is, the connection that we're using with Web3 here. And yeah, so now what we want to do is actually get the data that we want to send. All right. So how do we do that? So what is this data? Like if we're calling a smart contract and we're trying to say, call this function, like what's the data that we're actually going to send whenever we create this transaction? Well, the data is going to be hexadecimal encoded representation of the actual function name of the smart contract that we're trying to call, and it's also going to contain the arguments that function requires in order to send the transaction. Okay, so I'll explain that in a second, and I'll show you how to do that. So we'll go back to Remix, which we saw in the previous episode, where we had this smart contract, and this is remix.ethereum.org. This is the Dapp token that I've built out in some of my previous tutorials. You can check that out if you want to. And check on the details of this. This is the next thing we need is the actual smart contract, ABI, which I'll copy like this. And I'll say, I'll put this here, and I'm actually going to take this out, copy this, and say const tract ABI. Oops. All right. So what we want to do is get the data that's going to represent this smart contract function. And we can do that with the Web3 library by getting an abstraction of the smart contract. And the Web3 is actually going to give us a way to read the data that function would require in order to generate this transaction. I'll show you how to do that. First, what we want to do is instantiate a new Web3 contract. This is just going to be a JavaScript representation of our contract with the ABI and the address. Contract new web3.eth.contract. We'll paste in the ABI and the contract API and the contract address. Okay. Actually, yeah, let's do this. It's a Dapp token contract. And yeah. So let's figure out what function we want to call, All right. So this is our prerequisites. We need to know about this contract actually on the network. So we have the ABI that basically tells us like all the functions it has and a bunch of other information. And we have the address to tell us where the smart contract is located on the network. And now that we have this, we like know all the functions that are available and where the smart contract is. So we want to actually like find out what function we want to call and convert that down into some data that this transaction can understand. So let's see like, what external functions are available to this contract. We see the transfer function. This is the, this is part of the ERC20 standard, right? The token standard. This transfer function allows you to transfer tokens in this smart contract from one account to another. And this is the function that we're going to call. We're actually going to say transfer tokens from account 1 to account 2, right? So we're going to say we're signing this transaction from account 2, but we want to send it to the smart contract, right? Because that's who's in charge of managing tokens and balances, but we want to, send this function with the argument of the account that we want to send it to, right? And I'm going to show you how to do that. So in order to get the data, let's just say, we'll just do it right here. So we can get access to this contract's functions like this. Let's say Dapp. Actually, I'm going to shorten this. Let's just say contract. Contract methods, all right? And then we can say transfer. This is the function that we want to call. And then we can pass in the arguments. We want to transfer, let's just say 1,000 tokens. And this is, two arguments, address, and then the value. Sorry, did this backwards. I'm going to do transfer, let's see, account 2. And then, there we go. Yeah. All right, so those are the two arguments in the correct order. My fault, I had them backwards. So it takes two arguments, the address we want to transfer the tokens to, and then the unsigned integer amount of tokens you want to transfer. These are the data types, address data type and uint data type. So this is sending the tokens to account 2, we're sending 1,000 of them, and we want to now convert this down to data that the blockchain is going to understand. So we need a hexadecimal representation of this function name and its arguments. And Web3 gives us a way to do this like this. We say encode ABI. All right. So say let's actually just say this. Let's say data. And let's say const data. And let's comment all this out. I'll just show you what that looks like. Let's minimize this. This will also make sure that we get everything set up properly. We'll run this script with node app.js. All right, now that's what the data looks like that's going to get sent. This is just hexadecimal representation that's been compiled down to a way that our transaction understands. And that's the data that we're going to send whenever we call this transaction. So let's give it a whirl. Take this console logging statement out, and I'll run this. All right, so there's no errors, and we have a transaction hash. So let's see if this worked. We're not totally sure it worked yet. We got a transaction hash, but we want to make sure that we use enough gas and stuff like that. So let's see. You can go to Etherscan and paste this value in. Enter. All right, this is pending, so we'll wait a second. refresh the page. All right, so it was successful. At least it looks like it's successful. This says that this is the amount of gas used. This was the gas limit. It's pretty high. It was probably didn't need that many zeros. This is the contract that it was sent to. Remember, this is the contract address, and this was the input data. NC Etherscan has actually decoded this to say that, oh, you were calling the transfer function, and these were the arguments. Argument, yeah, you can see it. This is the address, and this is the value. So we can see the contract that we sent it to, right? Dapp token. We can see the list of transactions. This was the one that I created when I deployed it in the last video, and this is the the age of the transaction that I actually sent it to, like this. And yeah, let's go inspect this back in our script. So I'll minimize this, and I don't want to do this again, so I'll comment this out. Oops. And let's just log the value of account 1. It's pretty easy. We just do Web3, so the contract, methods, and then we say, balance of. It's going to get the balance of account 1. It should probably have gone down. I think normally it's 1 million whenever it gets deployed, but we transfer some tokens from account 1 to account 2, so it should decrease by this amount, 1,000. So let's see what happens. All right, yeah, it's gone down by 1,000. And let's check the balance of account 2. And try that. There we go. There's the 1,000 tokens that we've transferred successfully. All right, guys, so that's all I got for this episode. That kind of gives you an idea of how you can how a transaction works whenever you're calling a smart contract function that creates a transaction. This is what the transaction object looks like. You're sending this transaction. The recipient is the actual smart contract that you want to call the function for, and the data is just an encoded representation of the actual function that you're calling, along with its arguments. And Web3 gives you a nice way of doing that out of the box like this. You get the method from the contract, you basically generate the function call, and then you encode it. And then, whenever you're designating who is sending the transaction, you can sign it and turn it into a raw transaction, and then you can broadcast the raw transaction to the network. All right, so we're talking about, smart contract events. So if you're unfamiliar, smart contracts on the Ethereum blockchain can emit events. And essentially what that means is they can emit a signal that says that something happened inside the smart contract, and it can broadcast that event to the entire network. And a consumer can, subscribe to that event to find out that something happened with the smart contract. And we're going to look at, an event today that is part of the ERC20 token standard. And if you're unfamiliar with ERC20, this is just a standard for how tokens are built on the Ethereum platform. And I talk about that more in the previous videos, so you can check those out if you haven't already. So here I am on the ERC20 Ethereum improvement proposal page on GitHub. And the event that we're going to be listening for today and looking at is this transfer event, which you can see here. So this is an event that's part of the ERC20 standard. This is the Solidity source code for the interface that this event should implement. So essentially, this is the event keyword in Solidity, and this is the name of the event, which is called transfer. And it accepts a few arguments. The first argument is an address. This is the account that sent the transaction when they're transferring tokens, and this is the address that they're sending tokens to, and this is the number of tokens that they are sending. So what we're going to do is actually pull up an ERC20 token on the main Ethereum blockchain, the main network, and we're going to get these transfer events from the token. And we're going to see some of the past events that have actually been triggered by a smart contract with Web3 on the Ethereum blockchain. So we're going to do that with this with Web3, this library, with this event stream. We're going to get the past events for the smart contract. This is the source, the documentation that we'll be referencing to do that. And we'll go to Etherscan to actually find the address of an ERC20 token that we want to listen to. So let's go ahead and get set up. I've got a little sandbox here that I've been using for the other videos in this series. I basically just have an app.js file, and I'm going to be running this script with Node in my terminal here. And we need just a few things to kind of get us started. First, make sure you have Node installed. You can just check that out by typing node-v. And you'll want to make sure that you have the Web3 library installed. And you can do that like this, npm install Web3. Okay. So once you've got those steps completed, we'll go to this script file, and I'm going to paste in some boilerplate code that we've been using to get us started. Essentially what this does is it's going to require the Web3 library that we installed, and then we're going to actually create an instance of Web3 and pass it in a URL to a remote Ethereum node. And I show you how to get started with this link in my previous videos. You can check those out if you haven't already. For a basic explanation, basically you can go to infura.io and register and get an RPC URL for a node. And that's exactly what we're doing here. And this is connected to the main network. So what we want to do is, first of all, get a connection to a smart contract on the blockchain. We actually want to get a JavaScript representation of a smart contract. We want to say contract. And this is going to be web3.eth.contract. And we're going to pass it an ABI, and we're going to pass it an address. Okay. And you can check out the previous videos. We do this a couple of other times. Basically, this is using the contract part of Web3 to build a contract that we can talk to on the blockchain. And this gives us a JavaScript representation of it that we can call some methods on. So we need to define an ABI. Let's do this, and we'll paste the ABI here. Let me just do that for now. Actually, this is going to be an array. And we'll say const address. It's going to be a string. So let's fill these in. So we want to get an ABI for the contract. This is just going to be a JSON representation of everything that the contract kind of responds to and things like that. And then the address is going to be the location of the actual contract on the network. So let's go back to Etherscan to get those values. And earlier in this tutorial, we were using the OMG token. We were using the source code, not source code actually, the ABI and the address from this. So we can search for OMG and click on the contract, and we will look at the well, first of all, let's get the address. Copy this. Make sure you're on the main network, not a test network, and paste this in. And next, I'm going to get the ABI. Put it in the code tab. All right, so let's copy this. Go back to our file here. We'll paste that in. All right, now let's just try to run this. Console log contract. Sorry, I got a typo. All right, so let's minimize this and say I'm going to run this script like this, node app.js. Well, just as a reference, you don't have to include the file extension. We can just do node.app. All right, so I have a error here. I need to actually type new. It's my fault. All right, so we can see I console logged this contract that's represented by Web3. It basically destructures the ABI and organizes it in a fashion that can be useful for Web3. All right. So now what we want to do is actually get some events from this contract, and I'll show you how to do that. So let's go back to Etherscan really fast and look at this. If you look at these transactions, you can see there's a lot of pending transactions. Let's look here, token transfers. Actually, let's go to events. All right, and you can see this event stream here. We can see event log, transfer, 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 transfer. And this is exactly the kind of thing that we want to read with Web3.js. We want to get a list of these events. So I'll show you how to do that. Actually, let's go look at the documentation here. So what we're going to do is use the contract that we've instantiated, and we're going to call this function get past events. And we can pass in the event name and some options and a callback function that's going to actually return the value that we want here. We can see the parameters. This can be the name of the event, or we can listen to all of the events. Yeah, we'll kind of just play around with these, and I'll show you what they do. So let's clear this out, and we'll do just like what the documentation said. We'll do contract, and we'll say get past events, and we'll say all events. Oops. All right, and we'll say these are the options. So we can do from block, and we can pass it to block. All right, now and then we'll pass the callback function. This will take an error and an events. This will be. So I'm going to organize this a little bit so you can read it better. I'm actually going to bump up the code. Let's do it like this. This might be a little verbose, but hopefully it'll be a little more readable. All right. And I'll say console.log, and let's just say the events. Let's do the count. So what we can do is say from block 0 to block latest. All right, so let me explain what that would do. This was going to listen to any event that's triggered by the smart contract. We said we wanted to actually look for the transfer event, but this will include the transfer event and any other events that the token might emit. And this is sort of like the range in the chain that we actually want to listen to. So, with the Ethereum blockchain, you have block numbers. So basically, like anytime a token is transferred and this transfer event is triggered, right? This transfer event gets triggered inside the transfer function, right? Some tokens are being moved from one address to another. Transactions being written, and that transaction is getting stored inside of a block. That's what blocks are. They're bundles of transactions on the blockchain. Those are the blocks that get chained together to make the blockchain. And these blocks have numbers, right? See these numbers right here in the column, block. This is either the block number or the block height. I think that's actually the same thing. It might be subtly different. So like block 0 would be the first block, be the Genesis block, and then this number here. Let's see, 1, 2, 3, 1, 2, 3. I'll say 1, 2, 3. Yeah, 5,854,812. this is the block number all the way from zero base index up to this. So let's specify a block to start listening at, because if we started, from zero, it's going to be huge. There's going to be a lot of events come back. So we don't want to do that. So let's actually specify, let's kind of look here. Let's just copy this. And let's paste it in here. And if you're watching this video later, this number is going to be much higher for you probably. So let's just let's just start there. Yeah. Yeah, we'll zero this out a little bit. We'll start a little ways back, but not too far back. So I'm actually going to log this, and we're just going to see how many events, in all events, that were streamed. So let's say node app. All right, so undefined. Let's just see what happened. I made a mistake here. Oh, it doesn't know count, sorry. Sorry, I know too many programming languages. Sometimes I forget which, what I can do in each language. So yeah, 152 events were triggered, in this range. So we could, start here, turn these into zeros, see what happens. It's going to be much higher. It might even blow up on us. Yeah, let's not do that. All right, we'll see this as a 2. All right, so 623 events in that range. So let's bump this back up to, I don't know, I'm just kind of throwing some arbitrary numbers in here. So let's actually look at some of the events. 0. I think I went too high. Yeah, I went past the actual, I went past the number, sorry. Sorry guys, I'm just playing around here. Let's go back and take a look at what Etherscan actually says. Sorry. I think I also forgot a 0. All right, so now we've got a sensible length here. This is 152 events. So let's actually log the events. All right, so we can see the stream that came out here. This is all the events that were in that log. Let's just copy the last one. Let's just log the last one. Say events. How many was it? 152. All right, so let's do 151. All right, so let's copy this value. And let's, I'm just going to paste it in here so we can take a look. All right, so this is what, the event looks like in the stream. This is what a single event looks like. It's got some information here, some data. So we can see the address, and we can see the block number, right? This was kind of in that range that we specified. This is the transaction hash of the actual transaction that was written into the blockchain. This is the index, I believe, of the transaction within the block. So this would be index number 49. This is the block hash. This is the actual hash that corresponds to this block number. The log index, removed, false, ID. So these are the values, all right? Let's kind of talk about these for a second. So from, to, and value, these are the actual values that were passed in to the event that we saw on this GitHub page for the transfer event. We can see the 3 arguments, to, this is the transfer function, transfer event, from, to, and value. And we see that here as from, to, and value. This is who sent it, this is who received it, and this is how many tokens. That's a lot. So this is the name of the event and the signature, and this is all the raw data. And if you've watched my other tutorials about how to use raw data. This is an example. So yeah, that's a really good example of what the event looks like. And this is all data that you could use. So the reason this data is important is if you're building a decentralized application, you're working with transactions and events, you could build something like this on Etherscan, where you have a list of all the transactions. Here, I mean, more accurately, you could build something like this, or you could build a page that shows all of the events that were streamed from the smart contract. Now, what we can do is actually, we'll say length. Let's filter this. And let's say, let's actually change the name. So instead of listening to the transfer event, let's first see how many we have. Node app, 153 events. Let's say just transfer only. All right, so there's 151 that were transfer out of 153. So that means that 2 others were a different kind. Go back to our ERC20 standard. We can see that there's an approval event. This is the event that gets triggered when an approved transfer happens, like on a cryptocurrency exchange. So yeah, today we're talking about blocks, and throughout this series we've been kind of referencing Etherscan and seeing blocks like this. Like you can see the block number here, and we can see some information about it, like who it was mined by, and the number of transactions that are in the block, and the block reward, which is pretty high. So yeah, let's kind of talk about those and talk about how we can get this information with the Web3 library and kind of dig into blocks and what they're all about and see some data. So we're going to do this with the Web3 library with a couple of functions. We've got this get block number. We'll use this. This will return the actual latest block in the blockchain, or the block number. We can do get block, and we can pass in the block hash or the block number. And yeah, we'll just kind of start there and show you what you can do with Web3. So here I've got a little sandbox that we've been using to work in this tutorial series. I've got just a basic app.js file here and a terminal. Basically, if you want to follow along, all you need to have installed is Node Package Manager and Node. You can see if you have Node installed like this. And the only really JavaScript dependency that we'll be using today is the Web3 library. So you want to make sure you have that installed by just doing npm install web3. All right. So in this Node file, in this JavaScript file here, I've got some boilerplate code. Essentially, I'm just pulling in the Web3 library, and I'm instantiating a new Web3 object like this. I'm passing in this Ethereum node URL from Infura, and I show you how to get this in the previous videos. You can either watch those videos or just sign up for Infura and get an Ethereum node URL and paste it in here. This is just an API key. So when we do that, we'll actually have a connection to the main Ethereum blockchain. And we'll start off by using, we'll just get the latest block from the blockchain. We'll say web3.eth.get block number. We'll say then. So I'm actually going to show you this. In my previous tutorials, a lot I've been saying, passing in a callback function here, like we're doing get block number and then pass in a callback function, but you can actually just do a promise and say then, or do a promise chain, console log, just do that. And this will, oops, typo. All right, so we can see the block number here, and this is the latest block. Let's take a look on Etherscan, see if that's similar. refresh. This is, yeah, 081, and this is 081. So these seem to be in sync. All right. And when I say in sync, that means sometimes your Ethereum nodes can get a little out of sync. It's kind of a pain when you're developing decentralized applications with Ethereum. It's just a pain point that we all kind of have to work through. But it looks like this block number is the same as the one that Etherscan has. So that's a pretty simple thing we can do. We get the latest block number, and we can also get the latest block like this. We say web3.eth.get block, and we can pass it a couple of different things. We can pass the latest block like this, and we can run this, and that will return the latest block. We can log some information about this block. We can see the pass it a function. Say console log. See the hash. All right, we can see the block. Let's do this. And let's just say block number. Oops. All right. All right, you see that data? This is the actual hash of the block, and this is the block number. So we can get another block. You can also, instead of saying the latest block, we can also specify the block number like that. All right, and we can also specify the hash of the block. Probably need to do a string here. Oops. All right. There we go. So these are all the ways you can identify blocks when you're getting a block. We can also get like the latest 10 blocks with a similar way, but we would have to actually loop through them. So what I would do is say something like this: web3 eth get block number. I would get the number, and then let's just chain this and say latest. Pass it a function. We'll say latest. Yeah, let's say latest, and we'll actually loop through this with a for loop. We'll say let 0, and then I is let I equals 0, and then I is less than 10. Well, you get the last 10 blocks. I plus plus, and we'll say web3. .eth should get block, and we'll say latest minus I. All right, so it'll give us the last 10. We'll count down from 10 all the way down to 0, and we'll say then console log. We'll see the actual block. All right, that seems to be the last 10 blocks. Let's pass this a function. Block. Say console log block number. All right, we can see the latest 10 block numbers there. Same thing with the block hash. All right, see the last 10 hashes. Okay, so that's a neat little trick, but let's actually dig into the data of the block and talk about the data we actually get back. We'll do that like this. Let's clear this code out and say, web3 get block latest, and then we will say then, and then we'll say console.log. All right, so there's some data. Let's just pull our terminal over here. So we can actually see. I'm going to minimize this a second and just focus on the terminal here. So here's all the data we get back. This is all the information that's in a block. So this is, like the data that you'd see on Etherscan. If you click the block, this is a similar kind of data that we see in our terminal. We see the block difficulty. You talk about mining on the Ethereum network. This is basically the difficulty of the miner it has to overcome when solving the puzzle, right? When transactions are created on the Ethereum blockchain, it's a competition, and the competition gets harder and harder. People talk about the profitability of mining going down on the Ethereum network. That's because the difficulty is getting greater. We could see the gas limit and the gas used in each block. And this is the block hash. So this is, an identifier. We can, we use that to identify the block. We can pass that into the function. We can get on Etherscan and, paste this block hash in, and Etherscan will return it. Oh, it's actually looking for a transaction. Interesting. I don't know why that is, but we can see a couple other things. This is the address of the miner that mined the transaction. This is the one that won, the reward. This is the nonce for the transaction. This is the block number. This is the parent hash of the previous block. This is the timestamp that the block was mined at. So if you wanted to see, if you were to list the blocks out with the latest 10 blocks, you could convert this. I believe this is in seconds since epic time, if you're familiar with that concept. And we can see the total difficulty here. And this is the number, all the transaction hashes in here. And so I want to talk a little bit about the block size. And this is the size of the block in terms of bytes. It's not like the number of transactions that are in here. As you can see, this is, 25016. This is not 25016 transactions in length. This is just all the transactions that are there. So let's talk about the size a little bit. So we can see the size on Etherscan of the block size kind of over time. So we can see if you hover over any of these data points that the block size is actually the number of bytes that is contained in the block. So it's actually about the amount of data that's contained, not the number of transactions. So that's just an important distinction to know when you're reading this data. It's important to know what you're looking at when you see these things. But also know that, the transactions that are contained inside these blocks are, still important. These are the transactions that get bundled together to actually make up a block. And then the blocks, have a parent block of, the parent. Yeah, this is the hash of the parent block that is chained to this block. So these are the transactions that make up the block, and this is the other block that's chained together to make up the blockchain. And, while we're here, we can also do, a couple other things. We can get, block transaction count, and we can log this out to the console. You can see how many transactions are in that actual block. Oops. Uh-oh. I just made a typo there. Say app. Okay. You can see that there are 116 transactions in this block. So let's actually do get block. And we'll log out the, let's actually log out the block hash here. Oops. Another typo. All right, so here's the block hash. So let's actually identify this block. Sorry, this is kind of messy. The reason I'm doing this is I want to show you another function that you can use. So get block hash. Let's just call this hash. And then we'll say, what we can do is, I want to show you that you can do get transaction from block. I believe that's the right name. So we can pass it the block hash, the identifier of the block we want to call from, and we could just say we want to get the second one, or it will be 0 base index, so it'll be 3, I believe. And then we can just do console log. I think this will work. All right, there you go. So this is actually the transaction number 3, because this is 0 base index, that is bundled inside of this block. You can see block hash is the same, and the block number, and all that other data that we saw in the previous videos where we worked with transactions on the Ethereum blockchain. Let's go back to this kind of project template that I've been using throughout this tutorial series. I basically have just an app.js file here and a terminal where I'm going to run this with Node. So make sure you've got Node installed. Just go to your terminal, type node-v, check. And you want to make sure you had the Web3 library installed. You can do npm install Web3, like that. So I've got, this is boilerplate code here with this app.js file. And what I've done is just required the Web3 library from Node and from Node Package Manager. And I have created a new Web3 instance with an Ethereum remote node URL from Infura. And I'll show you how to set that up in the previous videos, so check that out if you're unfamiliar. The big picture is that you just need a link from Infura. You can sign up to get one of these, and I'm connected to the main Ethereum blockchain. So what we're going to do is kind of just walk you through some cool tips for Web3. So the first thing I want to show you is Web3's got a cool way where you can actually get the kind of average gas price on the network. So we do that like this. Web3.eth.get gas price. And we will just console log this. Okay. Run this. Oops. All right, we can see this value, and we could actually log this like this and say results. And we can use more Web3 utilities to convert this value to Ether. 3 from as utils, actually. And we can say results, say Ether. See if that works. Oh, I got to console log this. All right, it's a pretty small amount. That's the average gas price expressed in Wei, which is the smallest denomination of Ether, kind of like a really small penny, from the last few blocks. And it basically calculates the median gas price in order to show you that number. So that's a pretty cool thing you can use whenever you're trying to calculate the gas price currently for the network. Now, the next thing I'll show you is how you can have access to hashing functions with Web3. You can use SHA-3 like this, 3 utils SHA-3. This is a hashing function that we can use, and we can say Dapp University. Let's just see what happens here. Oh, sorry, I want a console log. All right, so you can see the hash value there. And there's a couple different things you should know about this. If you want to hash, like a number, you can do it like this. You need to wrap in a string. Because if you do it with a raw integer like this, it won't work. All right, so it needs to be wrapped in a string in order to run the hashing function, or you can use a big number. Oops, sorry, I don't have this pulled in actually. Yeah, I would just use a string. So one thing to know is that you can, if you're going to do a hex value like this, it also has to be inside of a string. You can't just do it raw. It won't work. Okay. This also has an alias, kcac256. I believe. I think that's right. Yeah. I always have a hard time spelling this. Yeah, it looks like I just had a typo. Sorry, I always misspell this thing. But yeah, that's the alias, is kcac256. And that just does the same thing. So you can see 3. See, the result's the same. And so Web3, important to know that Web3 will generate a SHA a little differently than Solidity will. And Web3 gives you access to the Solidity SHA-3 hashing function. Say Solidity SHA-3. Now, the reason to know about this is because it's going to calculate, the SHA-3 of the input parameters the same way Solidity would, which basically means that the arguments, they'll be ABI converted, and they're going to be tightly packed before they're actually hashed, which works a little differently than how Web3 does it. So another thing that you can look at is we can get access to a little bit of randomness. We can say like this. You can say web3.utils random hex, and we can pass in the length that we want. All right. And we can also pass in 0. All right. And we can pass in 32. Okay. So another really useful thing, and this is a nice little gem if you're kind of trying to debug things in the console. One of the things that always frustrates me about JavaScript is that it doesn't really have much of a standard library to speak of. And if you're coming from a language that has a lot of rich features, and sometimes JavaScript leaves a little bit to be desired, and I understand why. I mean, footprint really matters with JavaScript because it's designed primarily to run in your browser. And, we always have to worry about, how many features we have in a language like that. You don't want a really heavy footprint in the browser, so I understand. But sometimes, you always find yourself pulling in libraries to handle things. And one thing that Web3 ships with is _JS, which is a little known fact. So you can get access to the underscore library like this. You can say... I don't know if this will let me do this. Let's try this. Let's try this. Web3 utils. Well, first of all, let's just log this. Just to prove that it's there. All right. We can see all of the functions that are in the underscore library. If you're not familiar with it, I'll just show you. So, underscore JS is a library that has a lot of nice functions that allow you to do things you can't really do natively in JavaScript, or maybe some cleaner ways to do things, or just extend your JavaScript development experience. So instead of pulling that in with Node, you can have access to it. Sometimes this is helpful when you're debugging things in the console with Web3 and you want to use something like an underscore function. So for example, let's see if we can do this. It may have a naming conflict. Equals, we'll see if this works. Oh, it worked, okay. So let's say, for example, something you can do in underscore is say, we can use each, and we can map over an object. Let's just say key 1. We'll say value 1. And key 2, value 2. And we can pass this function. And we can say console log key. I believe the order is value key. I think so. Let's just see. Yep, I got it right. So you could basically pluck off the keys from an object and iterate over it, and just have access to the key value pairs. So that's like an example of something you can do with _JS, and now you know that you have it handy, prepackaged for you with Web3. So it's an example of a few things that we can do with Web3, and I'll kind of just show you more of the documentation with Web3. We can kind of pull this down here and say, I wanted to just kind of leave you with this, because this is probably going to be the last video in this series that I do, unless there's something else you all are sure that you want to see. Just notice that there's different, modules in here we looked at. We looked at the ETH or ETH modules, and saw a lot of things in there. You can do other things like the subscribe module. This is what allows you to subscribe to specific events on the blockchain, which is pretty cool. Allows you to listen to certain things. You can subscribe to syncing. If you're syncing a Geth node, you can always see if that's doing anything. We used contract when we were interacting with a contract. We used accounts when we were interacting with accounts. We were, doing things like that. There's personal. This is what you would use like with the the Ethereum nodes accounts, like if you're using Geth as the personal library. We kind of stayed away from that because I was trying to show you how to use Web3 with Infura remotely rather than interacting with Geth. So we didn't do much with the personal library. But just as a general explanation, an Ethereum node can basically have accounts, and like if you're running Geth locally, you can keep track of your accounts with the personal library. Let's see some other things. So one thing to notice here is this SHH. This is the library for interacting with Whisper. So if you're not familiar with Whisper is basically a protocol for like broadcasting messages across the network, and it's kind of devised for a communication protocol between dApps. But I know people are using it to create like chatting applications and things like that. So that's what Whisper is, and this is the part of Web3 that allows you to interact with Whisper protocol. And if you want to read more about that, you can just click this here.